So, yeah, the first experiment, you see which proton of the compound below would appear as a septet in the NMR. Septet means 7 peaks, right? And according to the 6 plus 1, n plus 1 rule, then the hydrogen should have 6 closed labels. And if you look at this, so you can see, yeah, only this one has 6 closed labels. 2 to 3 bonds away, right? So, there's 1, 2, 3, and here there's 1. So you can see these 3 hydrogen and these 3 hydrogen are equivalent, right? Are the same. And then this hydrogen has 1, 2, 3. 2 to 3 bonds away. And this hydrogen has 6 closed labels. Therefore, it should be 6 plus 1 equals 7, which is septet. This is n plus 1 rule. And for this hydrogen, it has only 3. 3 plus 2, 5. So you get sextet, not septet. Not septet.
Alexis, yeah, thank you.
So yesterday, a few of you came to my office and viewed their exam papers, and then some of them said, they may need more time to get into this exam mode. So, and then at that time I agreed, okay, we'll get another 3 points back. So you will get, you'll be curved. All of you, you see, the score, the grades on the exam paper you have now are those before curving, okay, and you will get 9 points. You get additional 9 points. Okay, and then one of you took the exam remotely, right? In the learning, in learning center maybe, in learning center. Took the exam through the learning center, and then he got 10 questions correctly. So you see, both point to the thing that you can get 9 points back. Okay, because normally I curve to the full. I know some faculty members curve to 97%, but normally I curve to 100%. Okay, and yesterday I just graded, and one of you got 10 questions correctly out of 13. Yeah, it's not easy. It's not easy. So we need to practice a lot. So you see, septet, right? For septet, it needs to have 6 closed labels, and only this hydrogen has. Only this hydrogen has. This hydrogen has 2 here, but if you draw 1, 2, 3, 4. 4 bonds away, too far, right? This hydrogen, 1, 2, 3, 4. 4 bonds away, too far, won't work. Okay. Only this hydrogen has 6. This hydrogen only has 2. 2 plus 1, 3. Yeah. 2. Only 2. Okay. Only 2. Only 2 closed labels. And then you see, and we discussed, right? For this hydrogen, these 3 hydrogens are equivalent. Therefore, they are not closed labels, even though they are 2 bonds away, but not closed labels, because they're equivalent. This hydrogen are equivalent. They cannot be considered as closed label. Okay. So, yeah. So this hydrogen has only 1 closed label, which is here. And even this hydrogen too far. 1, 2, 3, 4, right? So these 3 hydrogen and these 3 hydrogen, these 6 hydrogen are equivalent. equivalent, and they only have one closed label. So you get doublet for these 6 hydrogen. Okay, let's move on. So question 2 is quite challenging. So you see there are 5 distinct hydrogen, right? And then we can so we can count. Okay, have how many hydrogen? Here, hydrogen here. 1, 2. No hydrogen here. 1, 2, 3, 4, 5. Okay, that's good. And then you see for the two peaks around, for the two peaks in the range of 5 to 6. You see that? Then that's a very good indication of carbon double bond. That's very good indication. That's very characteristic. It's very characteristic for the for hydrogen attached to double bond to have the chemical shift in that range. In that range. So let's look at A. Okay, so here there's one hydrogen here, right? One hydrogen here, and this hydrogen has another 2 labels here and another 2 labels here, right? So it has 5 closed labels. I'm sorry, 4. Then it could have what? 5 peaks in one signal, right? Then that's the reason. I mean, it could work. Okay, it match because you can see for the most left peak, there's only one hydrogen, and it has quite a few peaks, right? This signal has quite a few peaks, and this matches the spectrum. Why? Because it has 4 closed labels, so it has the peak should. I mean, the signal should have 5 peaks, so that's correct. And then if you look at 2, it's 2 hydrogen. Okay, these 2 hydrogen have, it should be doublet, but here's kind of look like 3. And then we can have a question mark. Okay, we have question mark, and then we move on. Okay, we have question mark because there's some high resolution AMR, and then normally we don't work on that. Okay, there's some high resolution AMR, proton AMR. So then we can have question mark for this, but we cannot exclude. And then if you look at, there are 2. Let me see, from left to right. Maybe it's better for me to open my computer. Sorry, it's not. You have the exam paper. I don't need. It's better for me to open it. So move right on the other side. Okay. So, okay, if you look at this one, and even for this structure, okay, for this structure, and you have two, here is two, right? There are two hydrogen here, because these two belong to the double bond, okay, belong to the double bond, and there are two distinct hydrogen, and each of them has two. You see, two hydrogen here, two hydrogen here. And here is the three hydrogen. So you actually can compare A and D. A and D, they have the carbonyl group, right? And the only difference is that, they have this ester group, okay, ester carboxyl group. Yeah, carboxyl group, sorry. Carboxyl group is like that. The only difference is that this part is on the right. But for D, is this part on the left. Okay. You see that these two just switch. So this ether group here, and this group here. And then, okay, so, well, you can see the difference. And then we can first look at BCE. Okay, we exclude BCE first. If you look at B, B has how many distinct hydrogen? 1, 2, 3, 4, 5, 6. So B has 6 distinct hydrogen, right? So it's wrong. So we have to practice this. Right? There are only 5 here, but this here is 6. You can also judge from something, from some other information. For example, this hydrogen is here, is aldehyde, and you can check the table. Aldehyde, remember the chemical shift should be around, should at least above 6. Above 6, aldehyde. Yeah, actually aldehyde is from 10 to 12. So you can see this is wrong because this hydrogen, there's no such kind of peak. There's no such kind of peak. Maybe I need to lower down. Oh, yeah, I need to click all the time, otherwise it will. Yeah, here, you see that? This hydrogen, it should be above, the chemical shift is very high. So we need to know some very unique chemical shift. We don't have memorized all of them, but we need to have some rough idea. Okay, rough idea. And you can see, even though you don't know, you can see there are 1, 2, 3, 4, 5, 6. There are 6 distinct hydrogen, and here are only 5 of them. So B is wrong. And then you look at C. If you look at C, C is also wrong. So let me see this. So here, and actually this, you see this one, this hydrogen here, the chemical shift cannot be that high. Cannot be that high. You go check. You go check the table. There is connected to the double bond, carbon oxygen double bond. The chemical shift should be 2 to 3. Okay, 2 to 3. If you check the table, 2 to 3. So this hydrogen cannot be here. Cannot be here. This hydrogen should be 2 to 3. We need to have some rough idea. We need to have some rough idea. You go check you see for this hydrogen, it's 2 to 3, cannot be here. Okay. This was E. E, you can see this hydrogen must be what? Singlet, right? This hydrogen must be singlet. But this is not. Remember, because the hydrogen from hydroxyl group participate in rapid chemical exchange. So this hydrogen cannot have any coupling effect. Sorry, I need to keep touching this, otherwise. So BCE is wrong. You see, this must be singlet. Okay, but this must be the chemical sheet must be high, but must be singlet. There's no such kind of thing. So E is wrong. Then we're gonna have these two left. So which one? So which one? So these two, this, right? Okay, and this group, has three hydrogen. So must be correspond to this peak, this signal. Sorry. Then we need to determine. Here, these two. So, and this, which way is correct? And you can see here, there's two hydrogen here, right? These two hydrogen here have singlet and maybe doublet, right? And it is at a lower it has lower chemical shift. It has lower chemical shift. So this one, let me see. So this should be doublet. Okay, should be doublet. This also should be doublet because there's only one hydrogen here, right? There's only one hydrogen here. So these two should be doublet. Okay, and then if both of them are wrong, okay, this doublet should go here. Should go here. And which one is correct? No, it should be correspond. Okay, then we reword it. So these two, both are doublet, right? Both are doublet. And at a lower chemical shift. And then we want to compare which one is accurate. If we look at this structure, so this is at a lower chemical shift. What do you think? Is this one should have a lower chemical shift like this one? Will this one have lower chemical shift? So if you go back to check, both of so if you go back to check, this one should have let me see. This one should have higher chemical shift. Why is that? If you go back check, this current is connected to double bond. At the same time, it's connected to oxygen. It's connected to oxygen. So this one should have a higher chemical shift. But this, this doublet is at lower chemical shift. So A is wrong. A is wrong. Oh. Wow. So in figure 9.2, okay, in figure 9.2, you can see these two hydrogen are in the same range. These two hydrogen are in the same range. Okay, these two hydrogen are in the same range. That means with without this oxygen, this hydrogen and this hydrogen should be in the same range. Okay, should be in the same range. And now this hydrogen is connected to what? Connected to carbon that is attached to double bond. I'm sorry, connect to this oxygen, which is what? Which is what? Is hydrogen taking, right? So this hydrogen should have lower electron density than this hydrogen here, right? Because if we don't consider this oxygen, if we forget about this part, this hydrogen and this hydrogen should have similar chemical shape. If you check this, have similar. Because they are attached to the carbon, that is they're attached to carbon-carbon bond or carbon-oxygen double bond. Carbon-carbon, these two hydrogens should have very similar chemical shape. But if you look at the structure A, and then this carbon is further connected to oxygen. Therefore, this hydrogen should have a lower electron density. Why? Because the oxygen can take electrons. So this hydrogen should have a lower electron density. Therefore, this hydrogen should have a higher electron density. When it has a higher electron density, it has a lower electron density, then it should have higher chemical shape. If A is right, then we need to switch these two. If A is right, we need to switch these two. Yeah, so I know it's not easy for you to grasp all of this and then in such short period of time, but we have to. I mean, if you take any MCAT exam, this kind of spectrum will be provided to you. And you see, we detail the number of distinct carbons. Okay, I need to move quick. So red won't work well. So I should take some black Sharpies from. Okay, let's look at question 3. Okay, question 3. So question 3, the broadband have exhibit 5 signals. So we need to find a structure that have 5 distinct carbon. So we use you see, we follow the strategy, right? We replace this carbon with bromine. We replace this carbon with bromine, or we replace this carbon with bromine, or we replace this carbon with bromine or something else that's different from carbon and different from hydrogen. We can see if we replace any of them with bromine, they're the same. They're the same, right? They're the same. Then these 3 carbons are equivalent. Then this structure has how many distinct carbon? 1, 2, 3, 4. We use the strategy. Here we want to see whether they are the same or whether these 3 are equivalent. So we replace this carbon with something different. Or nitrogen or bromine does not matter. So you can see if we replace this carbon with bromine, or replace this bromine, or replace this carbon with bromine, they are the same structure. Therefore, these 3 carbons are equivalent. Then we have 1, 2, 3, 4. Same thing here. We have how many? You can see that these 2 are equivalent. These 2 are equivalent. We have 1, 2, 3, 4. 4 distinct carbon. And here you can see these 2 carbon are equivalent. And these 2 carbon are equivalent. We have 1, 2, 3, 4. These 2 are different. They are not equivalent because these are connected to chlorine. So we have 1, 2, 3, 4. 4 distinct carbon. So it's not right. Only this one. These 2 are equivalent. These 2 carbon are equivalent. You have 1, 2, 3, 4, 5. D is correct. And in this structure, I need to block the screen, otherwise it will black out. So for this one, these three carbon are also the same. I'm sorry, equivalent. So we have 1, 2, 3, 4. So only D is correct. Only D is correct. Okay, so I'm going to move real quick, and then you can. So let's look at question 3. I'm sorry, question 4. So question 4. Okay. Question 4. You know, the correct answer should be A. Okay, the correct answer should be A. And you can see there are 3 distinct hydrogen, right? 3 distinct. It's 1, 2, 3. Because these 2 carbon are equivalent. And I'm sorry, the hydrogen attached to these 2 carbons are equivalent. And the hydrogen attached to this carbon are equivalent. So we have 1, 2, 3. There are 2 hydrogen here. So A seems right. Okay. And then there are 4 distinct carbon. So this carbon is this carbon is distinct, this carbon is distinct, this carbon is distinct, this carbon is distinct. So 1, 2, 3, 4. Because if you cut this in half, the other side is the same. Right? There, you see that? So the 1, 2, 3, 4. Okay, let's see why the others are wrong. Okay. B, you look at B. B structure. Surely, I mean, these 2 hydrogen are equivalent. Okay, we have 1, we have 2, and because these 2 are equivalent. Okay, and these are equivalent. And we have, oh, actually we don't even take a look. If you look at this one, aldehyde, for the hydrogen in the aldehyde, you check, the chemical shift is in the range of 10 to 12. So B is wrong. B is surely wrong. We don't even count. We need to know some characteristic chemical shift. So this hydrogen, the chemical shift is in the range of 10 to 12. So B is wrong. B is wrong. Well, yeah. Let me see. So now we don't have much time. I will finish real quick. So we use this kind of strategy, to let me see. Oh, yesterday one asked D. Why not D? Okay. Why not D? Here I'll tell you explain. Okay. If you look at D, right? Okay, there are 3 hydrogen here, 3 hydrogen here, 1 hydrogen here, 1 hydrogen here, 2 hydrogen, 2 hydrogen here. But the problem is that for the hydrogen here has no close label, right? This hydrogen has no close label. These are the equivalent, but it has no close label. It has, you see, the closest hydrogen is here. If you look at this, 1, 2, 3, 4 bonds away. So for D, this must be singlet. For D, it must be singlet. Okay. Well, same thing here. This C is wrong, right? Because these are attached to hydrogen, and this other half, the chemical shift should be in the range 10 to 12. C is wrong. Okay, C is wrong. And if you look at this one, look at E. Oh, it seems right. There's 1 hydrogen here, 1 hydrogen here. Oh no. Oh yeah, 1. So here has 2 hydrogen. 2 here. 3 here, 3 here. So it's not right because, oh no, there's 1 here. So there are how many distinct hydrogen? There's 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, and hydrogen here, hydrogen here. There are 1, 2, 3, 5. There are 5 distinct hydrogens. So E is wrong. So E is wrong. Okay. Actually, there are. Yeah, we can find not only a few things, we can not only one thing is wrong for this, we can find other information that can tell this, they don't match. Okay, the structure here and the spectrum here don't match. Okay. So for question 5, so the base peak, what's the base peak? The base peak is different from the molecular ion peak. The base peak should have the strongest intensity, and here the strongest, the intensity is here. This peak has the largest intensity, right? So it should be around 20, close to 30, but not yet. So 29. The answer should be B. Okay, should be B. And then for question 6. So we have this kind of structure. Sorry, I have to go to my office to pick up one.